The multiplication rule, or the AND rule, is one of the major parts of probability and tends to come up in relation to the probability of one event happening and the probability of another event happening at the same time. So one of the instances we look at this would be when we have two mutually exclusive events, such as rolling a dice or tossing a coin, like we would have done in previous sections. So I've just drawn out the sample space for this. So essentially what that is, if we need a bit of a recap, is all the possible outcomes that can happen from tossing a coin or rolling a dice. So if we were to find just the probability of getting heads and a 6, we can see from our sample space that the only time this occurs is once, okay, out of the possible 12. So we would say that the probability of heads and a 6 is 1 out of 12. Now, how this links in with our AND and multiplication rule is to save us the time of having to draw out this sample space every single time. So the rule that we came up with was the probability of the event A, so in this case would be heads, and event B, in this case would be rolling a 6, is equal to the probability of A multiplied by the probability of B. So how we figure that out is we look at the individual probabilities of the events happening. So the probability of heads, if we were to toss a coin, is 1 out of 2, or 1 and 2, or a half. We know it's 50-50. Okay, probability of getting a 6 if we roll a dice is 1 in 6, or 1 out of 6. So following our formula then, we are able to multiply these, which should give us a half multiplied by a 6, which gives us a 1/12. This is the same exact answer as what we would have got up here from using our sample space. And notice how much little work we had to do there in comparison to drawing out the sample space as before. Now, going on to an example of this is if we have two people, Mary and John, they have their birthdays in the same week. We want to firstly find out what's the probability that Mary's birthday will fall on a Monday. So the probability of Mary's birthday on a Monday, Mary on a Monday, is going to be 1 out of 7, because one day on a Monday out of 7 possible answers that it could be. Now, both having their birthdays on a Monday. So this is where we're dealing with an AND situation. So this is the probability that Mary has her birthday on a Monday and John has his birthday on a Monday as well. So as we said before, this is going to be the probability of Mary having her birthday on a Monday multiplied by the probability of John having his birthday on a Monday. We know the probability of Mary having her birthday on a Monday is 1 out of 7, because we already found that in part 1. Probability of John having his birthday on a Monday is the same, as we know there's one possible day in the week that he can have his birthday on. And then our rule is to multiply these by each other. So if we're dealing with multiplication of fractions, we go top by top and bottom by bottom. So 1 multiplied by 1 is going to give us 1, and 7 multiplied by 7 is giving us 49. So the probability that both Mary has her birthday on a Monday and John has his birthday on a Monday is 1 out of 49. Okay, and now the third part, they both have their birthdays on either a Saturday or Sunday. So, probability of Mary having her birthday on a Saturday or a Sunday, and the probability of John having his birthday on a Saturday or a Sunday is equal to the probability of Mary having her birthday on a Saturday or Sunday multiplied by the probability of John having his birthday on a Saturday or Sunday. So see the way we're splitting up the two events here. We're dealing with two different people. That's our two events in this case. So the probability that Mary has her birthday on a Saturday or Sunday. So in that way, we're dealing with 2 days out of the possible 7. So we would say that the probability of Mary having her birthday on a Saturday or Sunday is 2 out of 7. We can also say that the probability of John having his birthday on a Saturday or Sunday is 2 days out of a possible 7. So when it comes down to it, then we're then going to follow our rule again, and we're going to multiply. So 2 over 7 multiplied by 2 over 7, follow the same rule, multiply the top by top and bottom by bottom. So 2 by 2 is 4, and 7 by 7 is 49. We can't simplify that any further, so that's going to be our answer. Alright, so essential part of this section is following this formula here. So the probability of event A and event B is equal to the probability of event A multiplied by the probability of event B.